Hello guys, this is Ravi Rajput. Welcome to my YouTube channel Next Gen Neuron. Today we will discuss a very interesting topic in AI, that is CNN or Convolutional Neural Network, or just think it as how AI identifies an image, right? Or how it recognizes an image. So basically it's a very interesting process, or it's a very interesting model architecture to which the image goes through and a magic happens. Yeah, we'll see that in detail. So one of the interesting things about CNN is like this is the same process of identifying an image the human brain also does, right? So, or I would say human brain also identifies the image in the similar way as CNN does, right? So CNN was totally a mimic of that process. So that's why this is going to be a very interesting topic where we will see the image goes through multiple layers of the model through various processes where the image is simplified, transformed, cleaned, and the output in a very suitable output to be identified properly by the model. CNN or convolutional neural networks are sophisticated neural networks consists of many layers. Right? Each layer has its own function. So what those layers are, let me tell you the name of those layers before we dive into much detail. Right? The first one is convolutional layer. Okay. The second is pooling layer. Third is fully connected layer. And fourth is output layer. Right? These are the four main layers or main components of a CNN. The first is convolutional layer, pooling layer, fully connected layer, and output layer, which is definitely the final layer. So now what happens through this layer with an image? So let me tell you. Let's take convolutional layer first. In convolutional layer, there is a very key component, I would say, which is there. It's called filters or filter. Yeah. So what that filter does, a filter is a 2 by 2 or 3 by 3 grid which slides over the image. Okay, this is a 2 by 2 filter, for example. It slides over the input image and extracts some important features out of it. So yeah, in computer world, yeah, images are made up of pixels, right? So all image are distributed as pixels. So consider the example of image 9, right? So an AI model has to identify if this image belongs to 9 or not, right? Or if it is number 9 or not. So how that number 9 will look like as a pixel. So let me tell you, or let's clear this one out. So yeah, consider this is an image grid for number 9. How it will look like: minus 1, minus 1, minus 1, minus 1, 1, 1, 1, 1, 1, 1, minus 1, minus 1. So if you combine all 1 together, it will form 9. See, right? This is number 9. So this is how images are distributed as pixels. Okay, so this pixelite image is passed through the convolutional layer as an input, and where the slider or a 2 by 2 slider or 3 by 2 3 by 3 slider, right? So let's take the example of 2 by 2 slider, which has its own weight, like for example 2, right? So which slides over the image, and what is the purpose of this sliding is to extract the important features out of it, or consider the filter as a magnifying glass. You are sliding a magnifying glass over the image and enhancing some of the basic components of the image or basic features of the image, right? So this is the purpose of a filter. So how it magnifies it, or yeah, how it does its work, right? So basically it multiplies its weight with the pixel. So how it will do that, just take the example of this 9, right? Or of this image, this one, how I'm going to multiply it with the filter. So for example, this 2 by 2 filter, if you are sliding from the portion of this image, so how it will do, first it will slide through this one, right? Let's take the example of this first portion of the image, which is minus 1, minus 1, 1 and 1. So this will be magnified. This will be magnified by the filter, right? 2 by 2 filter. So how it will do, how it will do it, right? So it will first multiply uh, the first component of the image, or the first pixel of the image, with its weight, like which will become 2 into minus 1 will be minus 2. This will become 2. This will again become minus 2. This will again become 2. So this is the resulting image. Definitely it's got many magnified, right? Higher pixels. So this is how filter magnifies the portion of the image, right? Similarly, it does the same thing with the entire image, or with all the portions of the image, right? So it magnifies all the portions, keep it separately as an enhanced version, right? Which will be combined together in the last layer, I'll tell you. So here I show you, I showed you the first portion got magnified. Similar way, when the slider is sliding from the next second part of the image, it will again will be magnified to certain output, say 2 2 2 minus 2, right? And so on. So this is the job of filter, to magnifying the portions of the image. Like, consider this is the first portion of 9, something like this, right? This is the another portion of 9, something like this, and the below portion will something like this, will be something like this, right? Now, what's the next layer is, that is the pooling layer. So before it goes to pooling layer, there is another magic which happens, right? So what is that? It's called ReLU. ReLU is an activation function, you know, which cleans the image, or I would say, like, it's a kind of cleaning the process. So I showed you the portion of the image, something like 2 minus 2 2 minus 2, for example, right? So what ReLU function does, ReLU function checks if the pixel is positive, it will keep as is. If it is negative, it will turn it to 0. It's a kind of cleansing process of an image, okay? So after this image from filter, magnified by filter, goes through the ReLU function, and the output will become as 2 2 0 0, right? All the negatives got turned into the 0, and positive as is, right? So this is an activation function, another process which happens before it goes to the before it goes to another layer, which is pooling layer. So what happens in pooling layer? So pooling is a downsampling process of an image, or I would say in easy words, it's a process to shorten the image, right? So what we did in our initial stages, our slider slides through the entire image, extract some important features out of it, and magnified those, right? The portion of the images, correct? And later on, all those magnified version of the portions, right, those were processed through the ReLU function to turn all the negative pixels as 0. So after that entire process, how does our image should look like? If you see here, these are the magnified version of all the portions of the image after getting passed through the ReLU function. So if you see, all the negatives got turned to 0. Okay, so this is the input to the pooling layer, right? So how pooling layer will perform its job on these portions? So pooling, as I mentioned, is a shortening of the process. So there are few mechanisms which are used to shorten the image, right? Even keeping the important information intact. So the first one, which is commonly used, is a max pooling. Okay, max pooling. Another one is average pooling, right? So let's take the example of max pooling. What it happens in max pooling? So in when the pooling layer applies the max pooling on each portion of the image, it tries to extract the maximum value of the pixel and remove the others, right? So how it will look like as an the output of the pooling layer, all the four portions will be, yeah, will be transformed to something like this. What is the max value in this matrix, which is 2, right? Or let me clear this screen. Okay, so after what should be the output of our max pooling layer? So the first image will look like this. Okay, the maximum of the first grid is 2. Similarly, the maximum of the second grid is also 2. Third one is also 2. Fourth one is also 2. So this, guys, this is a very simplified version of the image, right? That's why everything is 2. But in complicated versions of the image where there are different values of the pixels, you can see the difference, right? So the max pooling layer will pull out the maximum value of the pixel from each portion and keep it with us, or keep it with it even after keeping the other information intact. Okay, so this is all about the pooling layer. So after coming out from pooling layer, the output will be something like this, right? 2 2 2 2. Now it's a simplified version of the image having all the important features in it, right? So the next it comes is a fully connected layer, right? Which is the main layer where all the neurons of the previous layer is are connected to the all the neurons of the other layer, right? Or this layer. So what happens in fully connected layer, like it's a kind of flattening process happens here where all the components are, combined together to form the entire image, right? Consider like our filter extracted the eyes of a face, ears of a face, nose and lips or whatever, right, as a separate portion of the image, magnified those, and in fully connected layer all those portions are going to be combined together to form a full face, right? So here all the components of image 9 which were processed are going to be combined together to form complete 9, right? So this is the role of fully connected layer. So you saw the magic, right? So image got passed as an input as a raw image, right? Filter extracted the important features out of it, magnified those, later on cleaned the image, and as a part of pooling, it removes all the other wastage information and kept the maximum, yeah, kept the important information or maximum pixel, right, as an information, right, kind of shortening the image, right? After the everything is done, again all the portions combine together to form a full image back, yeah, back to the original version, I would say. So after the fully connected layer um, process completes, right, or when the image is completely combined together, so now the AI model identifies what image is that, right? So based on its training. So you are, that's a separate topic. I would describe how that training happens. So consider the model has been trained in such a way that it identifies what is 9. It knows what is 9, or how does the 9 looks like, right? So after this image, after the output comes out from the fully connected layer, the model identifies if it is 9, right, or if it is number 8, or it's whatever. So this is the entire process. It happens basically that this CNN model is a kind of classification model where it classifies all the images. So consider the example of a model which is identifying the difference between animal and building. I would also give give this example, the animal building example, to you guys in code. So where you pass the image of an animal, model will identify if it is animal, or if you pass the image of a building, model will identify if it is a building, right? So all these images, animal or building images, processed through these layers and getting classified if it is building or an animal. So this is all about, this is a summary of CNN model. Yeah, we'll see how it happens in code. That will make it much clearer to you guys, right? Okay.